Okay, so we started chapter 8 or unit 8 by graphing rational functions. Just to give you an idea about what rational functions look like, how a lot of times they'll have vertical asymptotes, horizontal asymptotes, okay? Unfortunately, not every rational function can look quite as easy as a few of the ones we've done. Some of them might look a little bit more difficult, but you can actually simplify them down usually. Okay, you can make the problem become a little bit simpler before you have to graph them or do something with it, okay? So that's really what we're working on here in 8.2 is we're working on simplifying rational functions, trying to make them become just a little bit easier to use or to graph or to do something with, okay? So we're going to use 4 operations. We're going to add, subtract, multiply, and divide rational functions. Multiplying and dividing is actually the easiest, okay? And you use exponent rules, you use some canceling rules. Yeah, it's easier because things cancel, all right? Just like multiplying and dividing fractions is a lot easier than adding and subtracting fractions, okay? The reason adding and subtracting is more difficult when you work with fractions is because you need a common denominator. The same thing's going to apply for us, okay? Multiplying and dividing, you just multiply and you divide, doesn't matter. So multiplying and dividing will be easy, so that's why we're starting with those, okay? Some of them might be as simple as this, all right? I have 5x cubed y over x squared y squared times y to the third over 15x squared. You've done problems like this before. Multiple ways to do this. Me personally, I could do one of two things. I might cancel some things first, or I might just go ahead and multiply them together and then cancel. Okay? That's probably what I would do. I would multiply them together first and then cancel stuff out. When you multiply fractions, you multiply across, right? So I'd get 5x cubed y to the fourth. And on the bottom I'd get 15x to the fourth y squared.
Yeah.
And then I'd just simplify. 5 over 15 would reduce to 1 over 3. X to the third divided by x to the fourth. When you divide, you subtract. 3 minus 4 is -1, but you never leave negative powers in your answer, so you make it a positive 1, but it'd be on the bottom, right?
Yeah.
Right? And then y to the fourth divided by y to the second would be y to the second, where? On the top, right? So final answer, 1y to the second over 3x. Or if you just put y to the second over 3x, you'd be in good shape. And that's as simple as you could really make it. Okay? That's kind of a real basic one. It goes back to just our exponent rules that we've done before. All right, any questions on that? Everybody have that?
Yep.
Good. All right. Do another one that'll be really good to have. This one down. Alright, so this starts looking a little more complicated. X times x minus 3 over x minus 2 times x plus 3 times x minus 2 all over x. In the last problem I showed you, I just went ahead and multiplied straight across the top and straight across the bottom right away. I would not do that here. Yeah, you could, but that's actually going to make this more difficult. Here, I would try to cancel stuff first. Okay? And when I say cancel stuff, If I would ask you to take 2/7 times 7/11, yeah, it's 14/77, right? But 7 and 7, they're both divisible by 7, so if I divide them both by 7 and make them both become 1s then, in a sense, and now multiply, I get an answer of 2/11. Isn't that easier to do then, as opposed to multiplying them together and then trying to simplify it back down? So if you can, try to simplify things first before you multiply it together. Alright? So in this case, this only works when you're multiplying, okay? I have this times this times this times this over this times this. Do I have some common factors? Do I have some things on the top that would cancel with what's on the bottom? Yeah, what's going to cancel?
X minus 2.
The x's cancel each other out,
X minus 2.
so those just become 1s.
X minus 2.
And the x minus 2's cancel each other out, so those just become 1s. And so really, all you're left with is what?
X minus 3 times x minus 2.
X minus 3 times x plus 3? X minus 3 times x plus 3? And I'll be honest, for our purposes, I'm okay if you leave it in factored form like that. I'm okay if you leave it as x minus 3 times x plus 3. Is it wrong if you multiply or FOIL those out? No, you can. X squared plus 3x minus 3x minus 9, you get x squared minus 9. I don't care which answer you use. Me personally, I just stopped once I got that far. But if you do multiply it out, it's not wrong. Okay? How's my time?
You're at 7 minutes.
7? Thank you. Questions on that one? Alright, let's try another one. 3x minus 12 over x plus 5 times x plus 6 over 2x minus 8. Do you see any common factors? Do you see any common factors like we had here that we could just cancel out? No. Okay? Are any of these expressions factorable? 3x minus 12 is factorable. Both terms are divisible by 3, or I could take a 3 out of each term. So that'd leave me as 3 times x minus 4. Everybody see what I did there? I pulled a 3 out of each term, so I wrote 3 parentheses x minus 4. 2x minus 8 is also factorable. Good. It would be what?
2 parentheses x minus. Oh, x minus 4 is cancelable.
If you don't see anything that cancels out right away, factor. Because then, after you factor, a lot of times what's going to happen is now you're going to have stuff that can actually cancel and simplify. x minus 4s cancel each other out. And now I have 3 times x plus 6 on the top. And what do I have on the bottom?
2x plus 5.
2 times x plus 5. Yep. If you want to distribute the 3, I make it 3x plus 18 on top. Go for it. You don't have to. If you want to make the bottom become 2x plus 10, go for it, but you don't have to. I personally would just leave my answer like this. Okay? Questions on that one? Everybody have it? Let's do another one. Let's do another one. X squared plus 3x minus 4 over x squared plus 4x plus 4 times 2x squared plus 4x all over x squared minus 4x plus 3. What do you think we're going to do?
Factor.
Factor everything. Everything that's factorable, let's factor. Can I factor this?
Yep.
Yep. What would it be? Tyler, take a stab at it. Paul, I'm coming to you for the next one.
X plus 4 and x minus 1.
Good. X plus 4, x minus 1. All this one.
X plus 2 and x plus 2.
Nice job. Who wants this one? Think greatest common factor. What can you take out of both terms?
2.
2 what?
X.
So what will it be?
So 2x parentheses.
2x parentheses x plus 2. Good. And how about down here? Somebody else, somebody different.
-3, -1.
So
X minus 3.
x minus 3 and x minus 1. Good. There you go. Got stuff that can cancel now, I bet.
2x.
There's an x plus 2 on the bottom, and there's an x plus 2 on the top. There's an x minus 1 on the top, can cancel the x minus 1 on the bottom. Is that it? So final answer, 2x parentheses x plus 4 over x plus 2, x minus 3. Okay. So there's an example of a bunch of multiplying ones.